Good afternoon or morning. Today we're going to spend some time talking about independent variables and dependent variables and how they relate to functions and how they relate to the words domain and range. And so you might have heard of independent and dependent variables before. Hopefully you have. So this is a Venn diagram. If we put things over here, they are qualities that only independent variables have. If we put something in this category, these are things that only dependent variables have. If I put something in the middle, it would be something they have in common. So let's start with independent variables. One word would be the input. We've been talking about input. We would find or graph independent variables along the x-axis or horizontal axis. In ordered pairs, these would be x values. A new word that we've learned that describes x values would be the domain. And so independent variables are domains. If I was looking at f of x equals x plus 3, the independent variable is the x. They change on their own, or you're going to be the one who can choose those values. We get to pick those values. So let's start at the bottom then. When we're involving statements that have independent and dependent variables, the independent changes on their own, but the dependent changes based on the independent. So I'm going to write down here at the bottom, this change relies on the independent variable. Okay, so I'm going to give the same statement. F of x equals x plus 3. The dependent is what f of x is. It's what it outputs, what the function outputs. So domain, remember domain is left to right. Okay. The dependent goes along with the range of values, and the range of values are up and down, are the y values. And so now that we just learned function notation, y values we also can write as f of x values. F of x is a fancy way of writing y equals. Dependent variables would be graphed on the y-axis. And they would be considered the output. So I've listed some things or some ways that independent and dependent variables are different. But how are they the same? Well, both of them are variables. That's one way that they're the same. Another way that they're the same is, for our purposes, both independent and dependent variables are going to take on numeric values. They're going to both take on numeric values, meaning that we are going to put numbers in their place. When we put the numbers in for X, we sometimes will choose those numbers, or maybe your teacher will choose them for you. The Y's or the f of X will depend on what we pick for those X values, but both of them are going to take on numeric values. Okay, so let's go through, and I'm going to use some highlighters, and I encourage you to do so as well. Let's go through some different ways that you might see independent and dependent variables, and I'm going to highlight things that are independent in yellow. I know I used that already. And then, maybe to be consistent, dependent I'll do with blue. We've just learned about something called function notation, and we put things into the function. When we're putting them into the function for X, okay, we put them into the function for X, those are independent, okay, and so those would be the X values. It's what I'm putting into the function. What comes out of the function is a number. After you put something in, something comes out. Okay, and so that would be f of X values, and the output, those are dependent. For example, let's do an example here. Let's say I said I'm going to pick 1 for X. If I put 1 in for X because I'm inputting it, that would be my input. F of 1, which is 3 times 1 plus 1, which is 4, would be my output, or my dependent value. Okay, so the X is independent. I picked what I put in for it. F of 1, or f of X, is the dependent. And so here's the numeric values that those things took on. All right, on a graph, where would we find the independent variables? We said on the x-axis. So those things you would see on the x-axis. So we would want to make sure when we're graphing things, especially when they are not x and y, that we figure out, hey, what is the independent variable? I want to make sure I put that on the x-axis. The dependent variable would go on the y-axis. On a table, the independent variables would go on the top if the table is written this way. The dependent would be written on the bottom if it was written this way. And on a table that's left to right, the independent is listed in the left column. And so that's why when we graph things, we should graph what's listed here on the x-axis. And the dependent would be listed over here on the y-axis. Okay, so what do I mean about quantities now, not x and y? Let's start to think about when values change other values. And so I'd like you to flip over the page. And we're going to do some of these together. You're going to finish them on your own, and you're going to do another worksheet as well. So we want to ask ourselves, which one depends on the other, okay? So Kelly works at a local dollar store. where she is paid $8.90 per hour. I highlighted the dollar symbol because that would be money. One of my variables is the money, and the other one is the time. Okay, does the time Kelly works, is that based on her money, or is the money that she makes based on her time? Well, in this case, because she's paid per hour, the hours worked, or the time, is independent, and the money she makes depends on that. All right. And this one, the time it takes to run a mile depends on the person's running speed. Okay, well, if I'm saying the time it takes to run depends on their running speeds, that means the time is the dependent variable. Time to run. And what does the time depend on? The time depends on the person's speed. Okay, next, the amount of time you study makes a positive difference on your next test score. So you're asking yourself, does the time depend on what you get on your test score, or does your test score depend on the amount of time you study? If you think about that statement, your test score depends on how much you study. So I'm going to make the test score dependent. The time you spent studying independent. Number 4. This is the last one we'll do together. The temperature of the water in Lake Michigan, that's one of my quantities, will decrease as the depth of the water increases. In other words, if you've ever been swimming in Lake Michigan and you're swimming and you get out to deeper water, you should probably notice that it's colder, okay? So does the temperature of the water depend on the depth of the water? Or does the depth of the water, how deep it is, depend on the temperature? In this case, the temperature of the water depends on how deep the water is. So the temperature of the water depends on the depth of the water. All right, so those are some examples of highlighting, trying to figure out what your two variables are, and then thinking about taking some time to think about which thing depends on the other thing.